So then it says, sometimes the quilt shop gets an order that turns out to be more or less the perfect square. Customer service always tries to fill orders with perfect squares, or at least they start there and then they adjust as needed. They always write their equations in a way that relates to the area of the closest perfect square. So for example, here's a real mess. Customer service received an order of an area of this. Oh, give me a second. So here's all this. Help them figure out an equivalent expression for the area to use the diagram. So basically, I gave you a bunch of pieces, kind of like what we did over here, except for instead of me giving you the expression, I gave you all of this. And your job now is to reorganize this into perfect squares. So can you try that in your brain? If you need to draw it out, draw it out. Drawing it out helps me. That's why I keep drawing it out for you. If not, you can kind of organize them the way you've been doing in your head. Okay. I'm going to pause so that you guys can take a chance to do this. Okay. So now that you're back, so what we're going to do is we're basically doing the same thing that we did previously, except for now they gave us all the pieces, the big squares, the rectangles, and the little squares. And you're trying to make the order make sense, okay? You're trying to make this order make sense. Okay, so the very first thing that I would do is I would pull these apart. So I'm going to make my squares a little bit bigger just because, you know, I have bigger squares to use. So I have this guy. And I'm going to move him down here. Oops, I don't want both of them. Just want one of them. Okay, so I have two squares. I'm not going to build both of them. I'm just going to build one of them, but the other one's there for the idea, right? So then it says I have 12 x's. So if I have 12 x's for all of this, how many x's does this one get? If I have 12 x's here or here, how much for both of these? How much does this one get? Exactly. So each one gets 6 x's, Ms. Johnson? Yes. Oh, because you split it. Yeah, I divided. Very good. Well, I didn't divide, your classmate did. Okay, fine. If this one gets 6 x's and this one gets 6 x's, how many x's go right here? How many x's go on this side? How many x's go on this side? Very good. Okay, so you want me to grab 3 x's, right? Yes. So let me just copy. I know, Ms. Johnson. It's like you're cheating. No, I'm not. I'm just being efficient. Look, see? Okay, copy that. Move down. Okay, so then imagine this thing to have the same exact thing. You guys all good on that? Very good. Ooh, we got some new people participating. Thank you very much. Okay, so then my question is, okay, so what do I do with this 13? What do I do with this 13? Well, I don't want to divide it in two because I know how many should go here. I know how many should go. How many go in this area here? Yeah, 9 go here. Very good. So, okay, very good. Very good. And because 9 go here, right? How many would I need all together? All together. Yeah, I'd need 18. Wait, Ms. Johnson. But you already have 13. Yes. So that means that I need to add more to this in order to make it a square. Does that make sense? In order to make it a square, I need to add more to actually make it a square. Does that make sense? I know it's weird, but just stay with me really quick. Okay. So this is 9. I'm just going to put a big 9 there because I don't have to like draw them out anymore. If I write 9 here, you guys aren't going to be mad at me, right? Big O 9. Everybody good? 9. I know that's not cheating, right? No, it's not cheating, Miss Johnson. Because look, I'm representing it. You guys all told me. Okay, so there's my 9 plus my other 9 is going to be 18. So the next question I have for you. Okay, then can you tell me how long this side is and how tall this side is? Yes. So I'm gonna talk about that extra what we're missing in just a second. Yes. So someone says, hey, Ms. Johnson, so that means this is x plus 3 and this is x plus 3. Exactly. So then can you write this as an area, but including this one too? Can you write this as an area, but including this one too? Kind of like how we did up here, this person, right? Can you write this one as an area? Both sides. If you can write this as an area for both sides, that would be fantastic. Good. I have one side. Can you guys do the other side as well? So this is what one person said. Hey, Ms. Johnson, I've got it for you. This is what one of my sides looks like. Someone said, Ms. Johnson, here it goes. Boom. That's exactly right. Two of them, right? X plus 3, x plus 3, x plus 3 squared. Perfect. Done. Can you give me the other side of this? What would all the little pieces look like all together? Ignore this for just a second. I know some of you are like, but Ms. Johnson, it says 13. Just ignore it for just a second. What would the other side look like? I'm talking about like this side. What would this side look like? Yeah, thank you. Very good. I appreciate that so much. This is like the equivalent of you guys coming up to the board, right? Except for now you have the ease of typing at your own computer. Very strong work there. And if you want to check the work, you should. It says 2x squared, check. It's 12 x's, so there's 6 here plus another 6 here. That's 12. 9 plus 9 is 18. Okay, me too. Me too. Okay, so Ms. Johnson, these are equivalent. Yes, they are. Okay, but Ms. Johnson, I don't understand because this one says 2x squared plus 12x plus 13, not your 18. I know, right? So we're going to have to figure out a way to write this. So this was much too much. Am I right? 2x squared plus 12x plus 18 is much too much. How much more is this than all of this? What were those extra pieces? How many extra pieces did we have? So remember, we had 13 pieces. So we imagine me going 1, 2, 3, 4, 5, 6, 7, 8, 9, exactly. 10, 11, 12, 13. And then you had this hole right here, right? Imagine this hole. There's an extra hole. Yeah, we need 5 more. We need 5 more. So yeah, kind of. I love that you did that. Oh my gosh, I gotta take a sniff of this. Someone said, hey, Ms. Johnson, would it be 2x squared? Oh wait, hold on, I'll be quiet. Let me just copy this. So someone said, hey, Ms. Johnson, is it gonna look like this? Oops, not like that. Is it gonna look like this? Is this what you mean? Is it this or is it this? Okay, now check this out. So if you look at this one, this is equivalent to this, right? So let me highlight. This right here is equivalent to this right here, right? Right? Do you all see that? So this is equivalent to this, which is equivalent to this, which is equivalent to this. All these things are the same. Now, I want it to say 13. So if I go from here to here, so let me say this again. If I'm going from here, oops, I don't want that. If I'm going from here to here, from here to here, what would I have to do in order to get it to be 13? Would I add 5 or would I subtract 5? Would I add 5 or yeah, I would subtract 5. So this person who's doing this is like some big thinking. I think you guys call it like big brain thinking or something like that, right? I don't know. I'm old, so There you go. So this is fantastic. I love that this person did this so strong. So do you see why this one doesn't make sense and this one does make sense? This one does. So yeah, we're going to have to subtract 5 in order to get from here to here. It's almost, yeah, big brain thinking, right? It's almost like you, I don't know. Have you ever done this? Like, I don't know. I do this all the time when I'm, it doesn't seem like it though. When I'm baking, like I'm like, oh, I added too much. And because I added it to the top of my batter, I could still take off the flour and it didn't affect the batter. Does that make sense? I did this last night when I was making sourdough bread and I put much too much flour, like not too much flour, but just much too much. And so I just took off a little bit and now I was good to go. So have you ever done that where you add too much stuff and you're like, I need to take it away? You just take it away? Yes. So that's exactly what I did here. I said, hey, I want it to be a perfect square, 2x plus 3 quantity squared. But then I added too much. So now I'm going to take away 5. This right here was so key. So if you're like, wait, why did she subtract 5, Miss Johnson? Why did she subtract 5? It's because we put much too much. So if you imagine all of the little squares here, I had 18 of them, but I didn't technically have 18. I only had 13 of them. So I had to take away 5 to compensate for that. Does that make sense? Very good. Okay. So then I'm going to have you do this one. It says Optima really needs to get organized. Here's another one. So can you do the same process on this one to see if you can come up with our correct answer here? Okay. Our correct answer here. And last but not least, what I'm going to do is I'm going to prove to you that this is the same by saying, by grabbing this. So if I take this right here, right? If I take this right here and I copy it, right? Wait, why did it do that? That's interesting. Okay. If I take, oh, I see why I did that. So if I take, not that, if I take this and I copy it, but I put it over here, right? But I make it small because that is the same thing as that, right? So let me highlight it. Right? And then I subtract 5, just like she said to do. When I subtract 5, I'm not like, if I subtracted 5, it'd be 18 take away 5, which is my 13. And that's why this equals this. Does that make sense? Okay. So what I want you to do is start working on this one. I want you to pause the video to see if you can do this one on your own and see if you can go from this to this. Okay. Okay, so the next one is number 7, and all you're doing is the same process that we just did. So the process is like kind of like divvying it up. And then someone said in the chat, like, so you're basically gonna balance it by if you added too much, then take away. And if you didn't add, if you need more, then you would add to it. Exactly. Right? Oh man, someone already has the answer in the chat. What? Right. Okay. Good. All right. So I'm not gonna build, actually, you know what? I'm gonna try getting you to think about this without the tiles. Now, if you need these tiles, then do it. Please do it. So, okay, can you imagine these 3 right here? Boom, boom, boom. And then you have 1, 2, 3, 4, 5, 6 of these. So if I have 6 X's, how many X's go for each one? How many X's go for each one? Very good. Someone said 2, exactly. So yeah, so this one gets 2 X's. I'm just gonna build this one because it makes more sense. So I'm gonna put a little rectangle here and a rectangle here. You guys all see it? Here's my little rectangles. I'm not even gonna build rectangles. I'm just putting sticks. Okay, so you can imagine me putting the similar thing here and here. So then how many little squares would need to fit in this to make a perfect square? How many would need to be perfect square? How many little squares? Exactly. I would just need one little square. So there goes my little square. Technically a dot. Okay, so I have x squared, x squared, x squared. And then I used up all these 6x's. But how many of these little squares did I actually need? How many of these little squares did I only needed 3, exactly. Oh no, oh my. I have way more than 3 squares. So what am I gonna do with all these extra little squares? What am I gonna do with all of these little extra squares, right? I have much too much, right? Yeah, you're gonna subtract them out. Very good. Or you're gonna add them, you're gonna add more too to get it, right? Okay, so this actually says, I'm gonna write this out as an expression first. So it says 3x squared plus 6x plus, I didn't even count these, 3, 6, 9, 10, plus 10, right, is equal to, now I have 3 sets of them, right? I have 3 sets, 1, 2, 3. How long is each side? How long is each side? Oh no, this one right here, this is just x plus 1, right? You guys all see that? It's x plus 1. Yeah, good. Okay, so this is going to be x plus 1 squared. Okay, now here's the thing. Before I write this one, I want to know how many I actually used. So I'm going to write this side as 3x squared plus 6x plus 3. Because that's how many little dots you said I needed. I only need 3 of these, Miss Johnson, right? Okay, but I need to go from 3 all the way to 10. I need to go from 3 to 10. So I'm going to go from 3 to 10. How do I get from 3 to 10? Yes, I need to add 7, Miss Johnson. Okay, so if I add 7 to this 3, are you saying this and this are the same? Are you saying this and this are the same? And you're like, well, yeah, Miss Johnson, look, 3x squared, 3x squared, 6x, 6x, 10, 3 plus 7. So you just want me to put a plus 7 right here? Yeah. Does that make sense? Very good. Very good. Okay. So again, the way I want you to check this is I want you to check to make sure that you know where this goes. So your answer for this one is going to look like this. Right? So here's your answer because these two are exactly equivalent. Does that make sense? Very good. Very good.